Good evening, everybody. I'm still in a different time zone, so... Okay, and I'm a bit nervous because I'm going to use an app I just downloaded. It's called Speaker Timer, and it counts down. But perhaps it has some surprises while I'm using it. I'm not familiar with the user interface. Okay, I already lost 4 seconds. Okay, so playfully learning visual perspective taking skills with Sifteo Cubes. Actually, most of the work has been done by Kevin and Ruben, the 2 master's students that I supervised last year, but they chose not for an academic career, but for a well-paid job in industry. And also Vero collaborated and ensured that there appeared some difficult words in the final paper. Perhaps I should first explain what visual perspective taking is, and I will do this by a very simple example for which I ask for your participation. So suppose I stand like this. Do you appear at my left side or my right side? So please raise your hand if you think that the audience is at my left. Okay, who thinks I'm at your right? Okay. That was the wrong question. You're right, Nicholas. Yeah, okay. Again, some seconds lost. Never mind, but okay, you know what this is about. So it's about knowing how the world appears to someone else. And typically, you develop this skill around the age of 5 years. So that was our target group, preschoolers. And for those who have been designing games for this age, they know that this is not an easy job. Okay, that's one part of the story. The other part is Sifteo Cubes that were already used by the previous author. Actually, this is the second Belgian presentation, beating Germany today. Okay, these are the Sifteo Cubes. Who is not familiar with them? Okay, a few people. So these are just little computers. You could say they have a screen. You can push it, so it's a button as well, and there's an accelerometer inside. And what they can also do is they know who is neighboring the cube. So this cube can know whether this cube is at this side of that cube. So for us, that's a very interesting technology. And perhaps I should be honest now, because when you submit the paper, you do everything it takes to get it accepted. But the story in the paper is slightly different from the true story. As we wrote in the paper, this was we had this problem, and we were looking for a technology to solve that problem. But this was not the case. Actually, we chose this technology because we thought this was an awesome game console, and we were looking for a problem to solve. So what we did is we went to a psychomotor therapist, and we explained her what these cubes can do. We showed some games, and she said, well, an interesting problem that you could tackle is visual perspective taking skills. Because in my practice, I have these boring sheets of paper with a lot of drawings on them, and typically I have to ask my child where, okay, if you are on the chair, is the ball at your left or at your right? And then the child has to say left or right, and then the child has to go through all that page. So from her experience, these children are not motivated at all to do these exercises. So, of course, then we end up with a game, and I don't need to convince you about advantages that game can give. Games can provide immediate feedback. You have rewards that motivate you. You can build up in complexity. And moreover, we would like to use the Sifteo Cubes, and I have this quote that I took also in my paper. Perhaps I just should read it. That embodied self-rotations through which we actively imagine ourselves assuming someone else's position in the world can subserve not only reasoning about where objects are in relation to someone else, but also how the objects appear in their environment. So we needed a game that can promote doing these self-rotations. So, and again, we thought that these Sifteo Cubes would be the perfect technology for that. Okay, what was our approach? And I don't think I need to convince you of this, but a good approach is that you do it player-centered, so you try to involve this target group in some way in the design process as soon as possible. For instance, we built some low-fidelity prototypes, and then we did some tests very early in the stage of, or very early in the process. And of course, there was the psychomotor therapist that could also give feedback on intermediate versions, just to ensure that we had a playable game. Because one of the lessons we learned from these first tests was that there was a huge variability in the children's competences. With these first prototypes, some children were not able to do one assignment correct or one trial correct, while other children, well, for them it was too easy. So that was one of the things that we should take into account. One of the solutions to that is providing scaffolding, so give some tricks or tips or hints during the game that can help the child to find the right answer. Another thing is that we needed to use objects that are easily recognizable from the top. Because first we worked with 3D avatars, but then you need the kind of projection on these small screens, and that was very confusing to them. So we chose a 2D environment with objects that are easy to recognize from the top, like a fish, for instance, as you will see in a minute. And also, I'm not going into detail here because it takes too long to explain, but we made some assumptions. Well, probably the child will do this after that trial, but it turned out that they did something completely different. Again, stressing the importance of doing this participatory design. Okay, so we built actually two games. The first game is called the fish game. It's played with 6 cubes. The main character is on the top left. It's the fish with the right wing in red, so that's one of the scaffolding tricks. In this case, there are 4 other cubes with a symbol. The child has to push one of these symbols, and then the fish says something like, "Put the red circle at my right side." And then if you do it right, you see some candy appearing. The fish goes to the candy, you collect candy, ends up in the box over there. But perhaps I just should show a small demo now. Okay. So the question is, put a square at my left. Okay, and I'm going to repeat that because there's something very important going on here, because it's something you cannot do with a paper test. So the child makes a correct answer, but see what he does first. He first is going to put the block at the right, and then he thinks and notices that's incorrect, and then he goes to the left. So we call this kind of action, one of the difficult words I learned through this study, an epistemic action as opposed to a pragmatic one. So it's an action that doesn't really bring you closer to the goal, but that helps you thinking, and that lightens the burden of the practice, of the assignment you have to do. Okay, and so he completed this level. Now there's another assignment. See, he draws away, he pushes away one of the blocks because he doesn't need it. So again, that lightens the burden of the task, and he can continue. And that's certainly one of the advantages of having these tangible games. You can do things that even on a tablet is not that easy to achieve. Also, this is a very natural thing to happen. There are no instructions given before. These things happen by itself. The second game we made was the penguin game. Now the idea was to physically distribute the cubes in space. So we had one cube, for instance, over here. We had one cube over there, one on that table, for instance, and one more in the back. So kind of in the 4 directions. So the idea was now that the child has to walk through space. There's one tile in the middle with a penguin, and when you push on the penguin says, well, there is a bird trying to steal the fish, and the bird is hiding in front of me. So the 4 other cubes, there's a cloud on it, and beneath one of these clouds a bird is hiding. You have to go to the right cube, shake it to scare away the bird. That's the idea of the game. So the idea was also to have a different interaction style here, and see whether the children had a preference for one or the other, or whether they had a better performance or so. Again, a small video clip for this one. So the penguin says the bird is flying in front of me. So in that case, the penguin was in the same direction as the player. See what she does now? Again, she see that the penguin is in the other direction now, and she took the same position as the penguin. So this helped her to solve the problem. Again, something they will not spontaneously do when you give a test on paper. Of course, we had different levels here. I'm not going through them in detail, but of course you start with easy levels, building up in complexity. Until a certain point you only train left, right, where your fish or penguin is always in a different direction than you are. So at the end you get really difficult levels. We did also a pre-test and a post-test, but we have to be careful here. We did not include a control group that did not play the game, so we have to be careful with the results. But we had the same symbols here, and in the pre and the post-test we simply asked, okay, if you were the fish, where would the black dot be? At your left, right, front, or behind you? And same for the penguin. We had 10 of these questions, just to explore, I should say, whether there were some learning effects. So, first of all, here you see the results, pre-test versus post-test, and you see there is indeed an increase. They learn something by playing the game, but again, we have to be careful here. I have to agree with the reviewers there. But it was significant. It was significant, but actually this was not first the most important thing. But because ideally you should have chosen a bigger sample and testing, or let them play during several days or so. Okay, but interesting for us was to see whether. Oh, perhaps I should again say, you see the variability here. Subject H, the last one, he could not simply do the test. He could not imagine what the answer would be. So you see this huge variability again. But then if you look at the levels they reach in the game, so actually if you have level 6 or 7, that means that you completed everything, all games. They did it within 10 minutes, which is really fast. So if you want to complete it in 10 minutes, actually you should not make any mistake, because you only go to the next level if you did not make any mistake. And actually this was the most interesting to us. If we compared these results with the pre and the post test, again here you see on average they make more than 50% incorrect answers, and here some of the participants they made no error at all, and on average we could monitor this. They had only 20% incorrect. And for instance, here you have subjects D and E that score around 50% on the pre-test and the post-test, but they could complete the game. So, and actually you rely on exactly the same skill. It's visual perspective taking. And for instance, subject H, who could not do the pre-test and the post-test, well, he reached level, let me see, 4 and 5. He got quite far there. So, of course, there are always differences between pre-tests and post-tests. One is on paper, because perhaps they were not motivated, or perhaps, well, you have to say the word instead of going to the right direction. There are differences between both, but still, I think there's a huge difference between the performance in the game and the performance on the pre-test and the post-test. Okay. I'm about to conclude now. And actually, if you cannot come with a question for me, I have one for you. Because there was some discussion we had. One of the reviewers' comment was, well, is this really 3D interaction? Because we claimed that a paper test is 2D interaction, and 3D interaction was what the cubes can offer. And indeed, if you just shift them on a table, you still can say that's only 2D. Or if you walk around in space, well, yeah, the floor, you stay on the floor, so you keep on moving in a two-dimensional space. But we think this is 3D interaction, because you can take the cubes, you can lift them and put them somewhere else. And when you walk around in the room, you are walking around in a 3D environment. So we think it's rather a 3D interaction, but I would like to hear your opinion on that. Okay, to conclude anyway, first of all, we were able to make games that are playable by preschoolers, from which we know that they have difficulties with that skill, but they could play the games and they were not frustrating to them. So that's certainly an added value of having these games. Secondly, tangible games are advantages for children to learn perspective thinking because of these epistemic actions, but we think that also for other learning problems that tangible games can be very advantageous. And finally, this is not really a scientific conclusion but a personal opinion, but I think that digital manipulatives, what these cubes are underexplored as a tool for instructional technology. Thank you for your attention.